So today I'm going to demonstrate how to build a capacity-only sediment transport model in 2D RAS. The capacity-only model is a way to kind of do simplified heuristic-based sediment transport modeling without mobile bed. And you still need to build a sediment file, but it's a simplified sediment file, and we can kind of move through it pretty quickly here. So I'll just show you how to do it. Here I've got a test data set. It's the test data set for capacity only, and will eventually be a 2D modeling test data set that comes with RAS. And what I've done is I've just computed flow through this reach with and without these four structures here. And so we have velocity plotted on the same scale, and if I turn on the velocity with the structures, you can see that more of the flows in the channel outside of the range of the structures, and you're getting higher velocity, which is great, and it gives us some indication of what's going on here. You could do it with shear stress and you can get a little bit more if this was a threshold channel, but it's not, it's an alluvial channel. And so having some estimate of the capacity, even in a fixed bed model, can be useful. And so what we're going to do first is we are going to create a bed gradation layer because the sediment model is going to need a bed gradation layer. And so I'm going to come over to my map layers. I'm going to right click. I'm going to create a new RAS layer, and I'm going to create a sediment bed material layer, just as if I was making a 2D sediment model. And here I'm going to, I like to change the name of it. And let's just call it bed gradation, bed grad, and save. And if I had a polygon here, I could add the polygon. I don't, I'm just going to draw it. So I'm going to press the create empty button, which is going to create an empty layer and let me define it. And so I'm going to go here and select bed grad for these. There's some evidence of my old work in there. And so now I have this layer called bed gradation. I'll go to the classification polygon and I'll start editing. And I'm just going to draw a big polygon that includes everything because the gradations here are relatively uniform. And I'll call this mostly medium sand. All right, and we could go in and define different values for different areas here, but this is a demo. And then I'm going to stop editing, say yes. And if you come in here and you go to layer properties, features, you'll see that we have one classification, mostly medium sand. If we had other classifications, we draw their polygons and name them there. And so now what we're going to do is we're going to come over here and we're going to open a sediment file. And so the sediment file has two tabs. By default, it opens to the boundary conditions, but we're doing capacity only, so it really doesn't matter what flux comes in at the upstream boundary condition. So I'll just click equilibrium load there. It's the easiest boundary condition, and again, it doesn't matter because we're not actually routing sediment, we're just computing capacity. And then we go to bed gradations, and you can see that our bed material type automatically populated here. Now, sometimes there can be a lag between creating this in RAS Mapper and it populating in the sediment file. If that's true, just kind of save everything, close it down, and open it back up. But here we've actually got our bed material type that we just made in Mapper there. And if we click on this dropdown, you can see we have one choice, a non-erodible surface, which is not exactly what we want. We want to define a gradation. And so here are the gradations that have been collected at this pool. I like to plot my gradations in monochrome so you can see if there's upstream and downstream trends. But here there's not a lot of upstream to downstream trends, and you can see that really the bulk of the material is in this medium sand range. And so we're going to do something like, well, let's call it 80% medium sand with 10% fine sand, 10% coarse sand. So I'm going to come in here and I'm going to define a gradation, and we'll call this mostly medium sand. And then I could go in and do that cumulative, but sometimes I find it's easier just to define the grain classes themselves. And so I'll come in and say, well, we're going to have 80% medium sand, 10% fine sand, and 10% coarse sand. We'll say, okay, let's save that as, and let's call it mostly medium sand. And so then I'm just going to close it and open it, because that sometimes helps with the connections. And so now if I come in here and click on this, you'll see we still have that non-orbital surface. That's always an option, but now we have this material, mostly medium sand. Okay, so all we've really done is defined our bed material. If you're going to compute capacity, you actually need to know what your bed material is. That's why you need a sediment file. But there's a couple other things you're going to want to do. You're going to want to choose a transport function. And so we're going to go to the bottom three are really designed for 2D, and we're going to use woo. The sorting method doesn't really matter because, again, we're not mixing the bed, and so it's going to ignore that. And then you choose a fall velocity method, Soulsby's great. So then you have to do one more thing. You have to come in here to options, and you have to go to 2D options. And we actually have to tell this model that it is a capacity-only model. And so we're going to come in here, and instead of all components, you can see there's a number of simplified analyses you can do. You can fix the elevation change and change the gradation, or you can fix the gradation and change the elevation if you're doing mobile bed models. A lot of times that's to hot start it and to get a hot start file that you're comfortable with. We'll do another video on concentration only, but the easiest mode here is capacity only. So all I'm going to do is select that, say OK, save, and I have a sediment file that is appropriate for capacity-only modeling. Because we're doing capacity-only modeling, I have a simplified hydrograph in here. I just want to see how the relative capacity changes as we step through a series of flows. And so I just have this monotonically rising hydrograph. And so now, if I open one of my plans and turn on the sediment button, now I've got a sediment file. So now I can say, let's save this plan as capacity only, no structures. Now I can compute. That took about 7 minutes to run 36 hours on a totally normal laptop. And so now if we go to the results, we have another result. And it looks like maybe we just only have the same stuff. This has got the velocity output that we've been looking at, but we don't have any sediment results. But that's because you always have to ask for sediment results. We don't provide any sediment results by a default, and so we're going to go here and we're going to say create a new RAS result. And so you get a really familiar editor, this result map parameter editor, except now you have this sediment tab, and sediment results are separated into bed and transport. Here we're just looking at transport, and you'll see we have two different types of sediment transport results. We have this total load capacity, which is actually broken down into total, fine sand, medium sand, coarse sand. You can add all of them, or you can add any one of them. And these are concentrations. These have units of milligrams per liter. And so, it's a little bit confusing because 2D RAS computes capacity in terms of concentrations, unlike 1D RAS, which doesn't in terms of flux. So these total load capacities are concentrations. Then the total load transport capacity, that is actually a mass flux. And that has kind of weird units. Right now, we're outputting that in units of linear pounds per second, or pounds per foot of the cell face per second. And so it gets a little bit awkward. I think we're going to switch that to a tons sort of output, but it is something that's a lot easier to evaluate visually. Okay, so I'm going to add those. I'm going to close. And now if we come here, you can see that we have not only the velocity, but we have these total load capacities. And we can look at how the concentration varies over time. And because we have a ramping hydrograph, it's going to increase. And so we've got the concentration going up to about 20 milligrams per liter. And then we can also do the same thing with the transport flux capacity. And so then we can also go to our profile line and we can take a look at what is our capacity. If we add them for both, we can actually turn them on for both. And we look at this flux capacity, say at this profile line, between these two structures, what is the flux capacity going to be here? I'll make sure that both of these are selected, and then I'll come here and I'll select face total load transport capacity. That's our flux variable. And you'll see that, we have a visualization of the difference between with and without the structures. Here's our capacity, again, in this kind of linear flux units of pounds per foot per second. But the thing is as you kind of look at it in this cross-section scale, you can see that the structures have dropped the capacity here between the structures in this zone right here, but have about doubled the capacity in the main channel. And because that's the level of precision that we're dealing with here, this is kind of a heuristic that we're looking at anyways, we can say that, hey, the capacity in the main channel has approximately doubled. You can actually come in here, and I have another video on this, and you can say create a new calculated layer, and then you could actually subtract these from each other and look at the actual difference in capacity that the structure gives you. And so that's just a little introduction about how this simplified assessment model works in the 2D sediment transport module in HEC-RAS. The idea is that you can get to some sort of screening level heuristic analysis without having to do a full-blown mobile bed sediment transport analysis. We have another video on this channel where we talk about how we actually applied that to a project. We'll link to that below, and we'll do another video on how to do concentration only modeling, which just is another level kind of intermediate between capacity only and full mobile bed. I'm Stanford Gibson. I'm the sediment transport specialist on the HEC-RAS team, and these videos were funded by the H Agency SET program.